Welcome. Today we are handling chemistry, just revising for the forthcoming exam, the waec exam. So we are going to treat some questions, and based on those questions, we will try to foresee what kind of questions might come up and discuss on the topics generally. Now let's start. This is just among the objective questions, multiple choice questions. So this is questions for 2022 waec multiple choice question. Let's go straight to the reason for this day. Number one, copper metal will react with concentrated calcium nitrate 5 acid to give A CuNO33 plus NO plus N2O4 plus H2O. B CuNO3 twice plus NO plus H2O. C Cu plus NO plus H2O. D CuNO2 thrice plus NO2 plus H2O. Just forgive me for the way I'm pronouncing those things. The answer is D. And that will make us to go into copper. I believe you have Ababio, new chemistry. So, you go under copper. The number one thing you will know about copper is it is a transition element, metal. It is a transition metal. And then, these are the things said about copper. Most electronegative elements in the first, please take note of this, first row of transition elements. The reason I'm bringing this up is if I bring any question under copper, so this will give you edge. Please take note of this. Electronegative, not among all the elements, but on this, in these few elements, transition elements, the first row. Another thing we know about it is it has a large positive electrode potential. Large positive electrode potential. Another thing we know is that it is low in activity series. Low in activity series. These two are saying the same thing. And relatively unreactive. Relatively unreactive. It has completely filled 3D orbitals. It has completely filled 3D orbitals. 3D10. Now, so this is the reason why it is unreactive or has stable nature. Reaction with air. When it reacts with air, it has green coating. Copper 2. Reaction with air. Now, reaction with air. When heated in here, when heated, it forms copper 2 oxide. Copper 2 oxide. So, this is what happens. They give us 2C. But if it is exposed to moist air or sea air, it's going to give us this one is black. It will be greenish. So, on exposure to moisture or sea air. So we are going to have something like this. Copper 2 tetra oxo sulfate 6. Triazocarbonates. Triazocarbonates. 4. So if exposed to C here, exposed to C here, you are going to have basic chloride. Basic chloride. The reason I'm doing this is if another question comes up about copper, you'll be able to handle it. Now, let's go to the real one they have asked us. The commonest acid used are H2SO4 and HNO3. We are told that copper doesn't react with dilute H2SO4, but it reacts with hot H2SO4. Punk reacts with concentrated. Please, these words are very important in chemistry. Dilute, concentrated. They are very, very important because they determine the outcome of reactions. We have the concentrated hot H2SO4. So what does it bring out? We will have plus 2H2SO4. So it's going to give us CuSO4 plus SO2 gas plus H2O. So you can see. Please take note of this. It's like all these things I'm writing is in case it comes out in your exam. The other one is this. When it reacts with, it can react with dilute HNO3 and hot punk HNO3. Let's see the outcome. So 3CuS plus 8HNO3. What does that give? It gives 3CuNO3 aqueous plus 4H20 plus 2NO. That is for dilute. You can see. That is for dilute. But when it is concentrated, you will see how it will react. Cu plus 4HNO3. What does it give us? CuNO3 plus 2H2O plus 2NO2. So you can see, when it is concentrated, it gives us nitrogen 4 oxide. When it is dilute, it gives us nitrogen 2 oxide. So please take note of that. You can see how tricky the questions can be now. So this is the answer. This is the answer to the question asked above. Let's see if there is another thing we need to know about copper. Now, how do they test for copper 2 ions? Test for copper 2 ions. We have flame test. Flame test. It will give bluish green. Bluish green color to non-luminous flame. Sodium hydroxide test. Sodium hydroxide. It will give us blue precipitate. Blue precipitate. We have Cu2 plus 2NaOH because it's sodium. It will replace the sodium there. You know, they will interchange in the salts. Now, aqueous ammonia. That is ammonia in water, dissolved in water. Blue precipitate will also be formed. Blue precipitate. So, in case you are asked in the exam, what are the tests that can be used? Maybe it's objective or theory. You're able to tell them about this, and this. So, and what are the uses? They are used for doing, what's it called? Manufacturing electric wires because it's ductile. Metal work because it is easy to work with, has attractive appearance, and is resistant to corrosion. It's also used in plumbing and roofing. 3. It is used in producing a wide range of important alloys, such as bronze, brass, copper, nickel, a mixture of copper and nickel. Then you can go and read about the compound of copper. Just brass too. So we have answered first question. Please don't joke with what I've told you now. Let's go to the second question. Now, the next question says, equilibrium is said to be attained in reversible reaction when A. All the reactants have been used up. B. All the products have been formed. C. There is no further change in temperature. D. Rate of forward and backward reactions are equal. E. The rate of formation of the product decreases with time. No. This D is the answer. It means that as products are formed, the whatever is formed too. The reactants are formed because it is a reversible reaction. So as forward reaction takes place, backward reaction takes place. And when the word equilibrium happens, here it is dynamic equilibrium. That is, forward reaction is equal to backward reaction. So D is the answer. D is the answer. The rate of formation of products decreases with time. This one happens in all chemical reactions, unless some other things occur along the way. Even if it is not reversible, this one happens. Do you understand? So, you can go through your notes on rate of reaction. So, the next one says, the acid present in protein is A. Lactic acid, B. Amino acid, C. Propanoic acid, D. Palmitic acid, E. Stearic acid. The answer is D. Amino acid. That's a common question. That's common. The next question says, the following are uses of sulfur except A. Manufacture of tetrahydrosulfate 6 acid, B. Prevention of growth of fungi, C. Vulcanization, D. Manufacture of dyes, E. Coating of steel to prevent rusting. E is the answer. We don't use it in coating of steel. Let's quickly run through uses of sulfur here. Sulfur is used to produce sulfur 6 oxide for manufacturing of tetrahydrosulfate 6 acid. 2. Sulfur is used in the vulcanization of rubber. 3. Sulfur and some of its products are used as fungicides and insecticides for spraying crops. 4. Sulfur is used to manufacture the bleaching agents used in pulp and paper industry. It's also used for the production of carbon 4 sulfide, skin ointment, and dyes as sulfide in manufacturing and sulfide as sulfide in manufacturing matches, fireworks, and gunpowder. Please run through sulfur and its compounds. Run through sulfur and its compounds. I also like to say some things. Its extraction of sulfur from its deposit is based on fresh process. It's based on fresh process. So it might be fresh process. Extraction of sulfur. That's one. And you can go through that. We also have allotropes of sulfur. That is the forms it exists. Allotropes of sulfur. So go through that, please. We have rhombic. We have monoclinic. Amorphous. We also know another one called plastic. So this one, they refer to it as alpha sulfur, beta sulfur, and delta sulfur. So please take notes. Go through sulfur and its compounds. You easily get that one. So we have its chemical properties here. It reacts with metals to form sulfide when heated in the absence of air. So gone through it, please, so you have edge in the examination. So the next question says the reaction represented by the equation NaOH aqueous plus HCl aqueous to give us NaCl and H2O is A. Double decomposition, B. Neutralization, C. Reversible, D. Usually catalyzed, E. Attains equilibrium after a few seconds. You don't even need to stress yourself. The answer is B. Neutralization. This is base. This is acid. You understand? And it's giving us salt and water. So that is neutralization. So please, we have treated this before. Go to your book and look at different types of reaction. Different types of reaction. So that's it. The next one says, which of the following compound is aromatic? A. Benzene, B. Cyclobutane, C. Cyclopentane, D. Hexane, E. Ethane. The answer is A. Benzene. The answer is A. Benzene. Basically, aromatic hydrocarbons. Let me even tell you what is written here. A special class of cyclic compounds. Not all cyclic compounds are aromatic, but aromatic is a subgroup of cyclic compounds based on benzene, C6H6, a 6-carbon ring compound. All other aromatic compounds are derivative of benzene. So we have phenylamine, that is aniline and phenol. We also have xylene. We also have xylene and toluene. We also have xylene and toluene. So examples: xylene, toluene, aniline. So all of this, the structure of this is based on benzene. You know, C6H6, like this hexagonal stuff. So take note of that. So you can go through it also, please. Now the next question says, which of the following does not affect the rate of chemical reaction? That does not affect it. We have 1. Addition of presence of catalyst. 2. Size of the reactive particles. C. Enthalpy change for the reaction. D. Concentration of the reactants. E. Temperature at which the reaction is carried out. So B will be the answer. Let's look at the factors discussed generally. 1. Energy content of the particles. 2. Frequency of collision of particles. 3. The activation energy of the reaction. Anything that can affect either of these will affect the rate of reaction. And let's look at what affects them. Nature of the reactants. Concentration of pressure, how close they are. 3. Surface area of the reactants. 4. Temperature. 5. Presence of light. 6. Catalyst. Now let's look at this back. Temperature is mentioned. Concentration is mentioned. Enthalpy change is mentioned. Size of the reactive compound particles. Addition or presence of catalyst is mentioned. So, size of the reacting particles. So, which of the following does not affect the rate of chemical reaction? Addition of presence of catalyst. Size of the reacting particles. The enthalpy change for the reaction. Concentration of the reactants. Temperature which the reaction is carried out. The enthalpy change for the reaction. Now the next question says, given that 32 grams of sulfur contains 6.02 times 10 to the power 23 sulfur atoms, how many atoms are there in 2.70 grams of aluminium? And we are given this information. Molar mass of aluminium is 27. That of sulfur is 32. So what does that mean? Let us check how many moles are there in what we are given. For Al, 2.7 grams is equal to 2.7 over 27 moles. This is 0.1 mole. And for sulfur, 32 grams is equal to 32 over 32 moles, which is 1 mole. Therefore, 1 mole will give us 6.02 times 10 to the power 23. Hence, 0.1 mole will give us 6.02 times 10 to the power 23 times 0.1 even by looking at the question, you must be able to give the answer straight. The empirical formula of hydrocarbon containing 0.12 mole of carbon and 0.36 mole of hydrogen is, what is it saying? It's telling us that the ratio of moles of carbon to hydrogen is 0.12 to 0.36. So that is, if you divide through by 0.12, it means that the ratio is 1 to 3. You understand? The ratio is 1 to 3. So we are going to have something like CH3. But in reality, you cannot have it like this. You understand? You cannot have it like this. So the most consistent answer is C2H6. So C2H6. That's the answer. You know, this one contains 4. And the outer 4 electrons at the outer shell. So this is the answer, C2H6. So the empirical formula of hydrocarbon containing 0.12 mole of carbon and 0.36 mole of hydrogen is CH3. Sorry, the formula is CH3. That is the empirical. Please take notes. I was talking about molecular formula. So this one is empirical. In the simplest form, that is what empirical is. Now the next one says, a source which uses mass when exposed to air is A, hygroscopic, B, deliquescent, C, efflorescent, D, fluorescent, E, effervescent. The answer is efflorescent. C. Efflorescent. Now, what happens? It loses some or all of the water of crystallization. That's what happens. So, for you to get this, you go and read under salt. Acid, base, and salt, I think. And other things might be of interest here. We have the deliquescent. These absorb large amount of water on exposure to atmosphere, so that they eventually turn to solution. Absorb, that is this one, absorb, and turn to solution. That is deliquescent. Let's look at the next one, hygroscopic. Absorb moisture from the exposure to atmosphere. If they are solid, they will not form solution, but merely become sticky and moist. This one will just become moist. This will become moist. Sometimes our salt, our Maggi, they experience it. And sometimes the Maggi can even become very liquid. It depends on the type or length of exposure. So this one loses water. This one absorbs to liquid. These ones absorb to be moist. These ones are not connected to exposure of salt. These ones are about electricity and lamp and light generally. Those are the last two. So note. And note these other definitions as well. Now the next one says detergents are better than soap for laundry because A, detergents are synthetic while soaps are not. B, detergents are more soluble in water than soap. C, scum is precipitated when soaps are used with hard water but not with detergents. D, soaps form soluble salts with ions causing hardness of water while detergents do not. E, soaps are in bars while detergents are in powder form. So the answer is C. You know, if the water is hard, soap will react with it and it will form scum. It will form some non-soluble salts. And this might affect the cleanness of the salts, of the clothes or the laundry. So it might even stain the laundry. That's why detergents are better than soap. So this one is under, I think under water, hardness of water. So please check that topic too. Hardness of water. So please, just glance through. So the next one says, which of the following is used as an anesthetic? These are the things given in the options. CHL3, CHCl3, CH3OH, C2H5OH, and CHBr3. The answer is D. So take notes. It might show up again. So you can go and read under Incase. You understand? And we get some of these compounds and their uses. Organic chemistry. Let me just put it that way. Now, the next one says, which of the following types of hybridization give rise to tetrahedral molecules? ASP, BSP2, CSP3, sp3d, esp3d2. The answer is sp3. sp3. Just look at that. So you go to shape of molecules. Go and check under shape of molecules. You will see that of methane. You know, instead of this being filled up, it moves one of the S here, you know. The carbon this thing should be S2, 1S2, 2S2, 2P2. But instead of that, it moves one from here and goes to this place. So that is the hybridization that occurs. So that's why we have it as sp3. So check shape of molecules. Shape of molecules. So go and check under this. You will see that of S2A3. That is, I think that's triangular for ammonia. For water, let me see. What's the shape for water? Which of the following is a neutral acid? A. Nitrogen 4 oxide. B. Carbon 2 oxide. C. Sulfur 4 oxide. D. Phosphorus 4 oxide. E. Nitrogen oxide. The answer is E. Nitrogen oxide. So you check nitrogen and its compounds. Which of the following statements is not correct? A. Carbon exhibits allotropy. B. Sulfur exhibits allotropy. C. Chlorine exhibits allotropy. D. Nitrogen is a gas. E. Argon is a noble gas. The answer is C. Chlorine does not exhibit allotropy. You can only have isotopes of chlorine. And meanwhile, chlorine is a gas, so you cannot attach any shape to chlorine. So for you to understand this, you have to read about carbon, sulfur, nitrogen, chlorine, and argon. That is their properties. Now, the following are uses of radioactive isotopes, except for A. Sterilization of medical equipment. We know they use it for tracing reaction paths, dating elements, radiography, determining equilibrium positions. So the answer is E. You cannot use it to determine equilibrium positions. Next one says, the main characteristic feature of transition metals is that they A. have the same atomic size, B. are reducing agents, C. form ions easily, D. have variable oxidation states, E. are highly electropositive. The answer is D. They have variable oxidation states. addition methods to get the answer. The following are heavy chemicals except A. Tetraoxosulfate 6 acid, B. Caustic soda, C. Sodium triisobicarbonate 4, D. Ethene, E. Dyes. The answer is dyes. E. The next question says, what quantity of silver is deposited when 96,500 coulomb of electricity is passed through a solution containing silver ions? The information given is that Ag is 108 grams, that is molar mass, and 1 farad is 96500 coulomb and 6,500 coulomb. So what happens? Because Ag has +1 valency, it will require 1 farad to give us 1 mole. You understand? So what happens is that 1 farad now is now supplied, that is 96500. 1 farad is going to give us 1 mole of Ag, which is equal to 108 grams. So the answer is E. So we have this question. Bombing of carbon dioxide into calcium hydroxide solution results in the formation of A. CaCO3, B. CuCO3, C. ZnCO3, D. Na2CO3, E. NgCO3. This one is no brainer. No other element are there. We have only calcium, carbon, oxygen, and hydroxide ion. So the only answer is A. Calcium carbonate. Which of the following is not decomposed by heat? A. CaCO3, B. CuCO3, C. ZnCO3, D. Na2CO3, E. NgCO3. The answer is D. Na2CO3. So we have, which of the following is not true of the rusting of iron? A. Rusting is a reduction process. B. Rusting of iron takes place in the presence of oxygen and moisture. C. The rust form is reddish brown. D. The major constituent of rust is hydrated iron 3 oxide. E. Rusting is similar to burning. The only answer we have here is rusting is a reduction process. That's a lie. Rusting is oxidation process. So you can read under iron and its compounds. And as well, you can try to get the process of rusting and prevention of rusting or protection of iron from rusting. So you can read that all. The question says, what volume of oxygen will be left unreacted when the mixture of 100 cm3 of hydrogen and 200 cm3 of oxygen are exploded in a iodometer? Let's look at how it goes. We know that when hydrogen and oxygen react, they are in the ratio of 2 to 1. We have it, hydrogen, oxygen, to give us H20. So let's balance the equation. We have this one to be 2, and this one to be 2. So it's balanced now. So it means that the two of them, this one should be in the ratio of 2 to 1. Now, if we have oxygen of 200 cm3 and hydrogen 100 cm3, one will be exhausted and the other will remain after use. Let's see. If this one is 100, since it is 2 to 1, this one must be 50. Do you understand? If we use 100 cm3 of hydrogen, we will require 50 cm3 of oxygen to balance it. But now we have 200 cm3 of oxygen. It means that we are going to be left with 150. Therefore, the answer is C. So you can see it's very simple. C is the answer. We just use knowledge of stoichiometry. So from here, let's look at what will happen. We have hydrogen combining with oxygen to give us H20. Now let's balance the equation. 2 here, 2 here. So which means that it will be in the ratio of 2 to 1. So it will be in the ratio of 2 to 1. Now, if 100 cm3 of hydrogen combines with, it will combine with 50 cm3 of oxygen to give us that volume to balance. And now, after using 50, it means that we still have more oxygen because we are provided with 200 cm cube. So let's see how many will remain. This is 200 here. So it means we have 150 cm cube of oxygen remaining. So the answer is C. Aqueous sodium triisocarbonate 4 solution is alkaline because A. Acid from which it is formed is strong. B. Sodium is an alkali metal. C. Sodium triisocarbonate 4 is decomposed by water. D. Sodium triisocarbonate 4 is stable to heat. E. Sodium triisocarbonate 4 is hydrolyzed in water. E. It is hydrolyzed in water. That is, it separates the water ion, and from there it forms some kind of a bond which gives rise to alkaline solution. So the answer is E. Right. Which of the following correctly explains why iodine crystals change directly into gaseous states when heated? A. Iodine crystals are sublime. B. Iodine atoms are held together by strong forces. C. Iodine molecules are held together by weak forces. D. Iodine molecules are covalent. E. Iodine is a solid at room temperature. The only answer consistent with the question is C. This one is explaining the same question again. You can see here they are talking about atoms and strong forces. If strong forces are holding them together, they won't sublime. So C is the right answer. This one is still saying the same thing. So the answer is C. Now, which of the following is a waste product in the solvent process for the manufacture of sodium triisocarbonate 4? A. Ammonium chloride. B. Brine. C. Limestone. D. Calcium oxide. E. Calcium chloride. The answer is calcium chloride. E. And for you to get more about this, go and read about the industrial production of sodium triisocarbonate 4 and also about the manufacture of sodium as well. So you will need to read about solvent process, Haber process. I think that one is for triisocarbonate, tetraisophosphamate 6 acid. So please try to read up those ones. Solving, Haber, and other ones like that. When copper 2 chloride solution is treated with excess aqueous ammonia, a deep blue solution results. This is due to the presence of A. CuNH4 3 plus ion, no. CuCl4 2 minus, no. CuOH4 2 minus ion, no. CuH2O 4 2 plus ions, no. CuNH3 4 ions. I think this one should be 2 plus ion. So the answer is E. The answer is E. So you get that one under copper and its compounds. The complex salts formed when aluminum dissolves in sodium hydroxide solution is A. Na3AlOH4, Na2AlOH3. These two are not consistent because by the time you have 3 Na plus Al, that's 6. So this one is not correct. This one is not correct. NaAlOH3. This one is okay. Na4OL, no. NaAlOH4. Okay, this is the correct one. So E is the correct answer. Now if you look at this one, plus 3, plus 1, plus 3. And this one is minus 4. So this one is balanced. So the answer is E. So the question says, the reaction represented by the equation C plus H2O gives CO and H2 gas was carried out at 27 degrees Celsius. If the enthalpy change was 4,500 joules, this is 4,500, and the entropy change was plus 12 joules, what was the free energy change? And we are given the equation. Free energy equals to change in enthalpy minus temperature times change in entropy. Now, our delta G will be equal to 4500 minus what is our T? Remember, 27 degrees Celsius is equal to 300 Kelvin. That is 273 plus 27. That's 300. So we have minus 300. And what's our entropy change? Times 12. So tetragosulfate 6 acid solution. 0.05 mole of electrons were passed. What volume of gas was produced at the anode? Gaseous molar volume equals 22.4 dm cube at test state. A 0.224 dm cube. B 0.280 dm cube. C 0.560 dm cube. D 2.24 dm cube. E 22.4 dm cube. What happens is that oxygen is produced at the anode, and to produce 1 mole of oxygen, because we are going to have, which means we are going to need 2 times 2 moles of electron. So to produce 1 mole, we will require 4 moles of electron. We require 4 moles of electron. Therefore, 0.05 mole. Okay, 1 mole of oxygen. Sorry. So 0.05 of this will give us x here. So x over 1 is equal to 0.05 over 4. That's what. So which means that to produce 1 dm cube here, we need 4 moles. So 0.05, how many volume is that going to give us? That's going to be 0.1 over 2 times 4. That is 0.125 times, and this is the whole. And we multiply this one by 22.4. So volume produced is equal to 22.4 times 0.125. Or let me make it like this. Instead of this, let me say 22.4 dm cube. We require 4 moles of electron. So x will be produced by 0.05. So here will be x over 22.4 times 0.0. So this one, I think this one is clearer. So this one will have, so x will be equal to 0.05 over 4 times 22.4. So that's going to give me like 0.1 over 8 times 22.4. And that's going to be C. So the answer is B. The answer is B. So here I got 0.28. So the answer is B. The major raw material in the plastic industry is A. Ethanol, B. Sulfur, C. Methyl ethanoate, D. Ethene, E. Ethane. The answer is D. Ethane. Ethene, sorry. So the question says, which of the following reactions represents laboratory preparation of hydrogen? A. Carbon in water to give us carbon monoxide and H2 gas. B. Sodium in water to give us NaOH and H2. C. Zinc in HCl to give us ZnCl2 plus H2. D. Copper Cu in H2 to give us CuO and H2. E. Aluminium in H2 to give us Al2O3 plus 3 H2O. So, in the laboratory, this is what we use, ZnHCl. So this one is liquid form, and this one will evolve as gas. So this is it. So you can read on laboratory preparation of hydrogen gas for that.